Hello everyone, I'm Norman Wildberger. Today's video is called Scale, Adjacency, Sharps and Flats. I'm moving towards the notational system that we use to represent music on a page. And to do that, I'm going to look at these scales and the connections between scales in a rather mathematical way today. And we're going to see the circle of fifths or fourths, or better yet, 5 steps and 7 steps appear again. And this connects very naturally with the standard conventions for sharps and flats to denote different key signatures found in modern music. So to motivate us a little bit, let me just move temporarily into the world of pure maths for a second. And let's consider the situation we just have 5 things, say the numbers 1, 2, 3, 4, 5, and we're considering 3 sets from this set. So in other words, we're considering subsets with 3 elements, like 1, 2, 3, or 1, 2, 5, or 3, 4, 5. Now there are 5 choose 3, which is 10 different such subsets, and here they all are. They naturally make a little triangle like this because it's actually the same as 5 choose 2, which is a triangular number. Now, what I've shown you here is a kind of adjacency. We can create what's called a graph in mathematics by connecting some of these subsets. We can decide to say that 2 subsets are adjacent when they differ by exactly 1 element. In other words, when they're almost equal but not quite. So for example, 1, 2, 3 is connected to 1, 2, 5 because they overlap with the 1 and the 2. They just differ with the 1 element, the 3 and the 5. On the other hand, 1, 2, 5 is not connected to, say, 3, 4, 5 because the intersection between these two is just the 5. So these are not as close as these are. Well, then each one of these things is connected to 6 others. For example, 1, 2, 3 is connected to these 6 here. And we get a pleasant, rather symmetrical kind of configuration. And this is the kind of thing that abstract pure mathematicians like to study. So we like to stare at these kinds of things and sort of, see if there's any other interesting patterns or things to count. So for example, we might observe that here, these 3 here form a little triangle because this is connected to this, is connected to this, is connected to this. So there's a little triangle there. And we could ask, well, how many such triangles are there, and we could sort of analyze this and maybe even try to see if we can visualize this perhaps in a more symmetrical way, like maybe it's really a polytope. In fact, you could actually think of it as a polytope if you go up in dimensions and think of 5-dimensional space and think of one of these, like 1, 3, 5, as being a vector, say the vector E1 plus E3 plus E5, that combination in this 5-dimensional space. Then you could actually sort of create this essentially sort of 4-dimensional polytope, which represents this. So I'm just giving you this as a motivation. We want to look at something like this in the context of major scales in our usual musical framework. And I want to look at it a little bit from this sort of abstract mathematical point of view, just briefly, to bring out certain rather interesting features that especially connect with this story of key signatures. So let's look at the major scales that we talked about in our last video, and I showed you how various translates of a scale can overlap in different ways with an original scale. And from that point of view, there's a kind of a sense of scales being close when their overlap is maximal. And for a major scale, that actually happens when you have an overlap which is all of the notes except for one, or all of the tones except for one. And so if we make a diagram, like a graph, much like I just showed you in the previous slide, but now for scales, then we get a circle. So what's represented here are the 12 various scales, starting on our 12 different tones, 0, 1, 2, up to 11. And throughout, here's our basic interval sequence for a major scale, 2, 2, 1, 2, 2, 2, 1, which I hope you've all learnt. And here are the various scales then. So this is the scale starting on 0. And I want to emphasize that you can think about 0 as being middle C if you're, say, a piano player, but you don't have to. And so, for example, if you're a guitar player, it might be more convenient to think about low E as being the bass or standard note named 0. And maybe in some other context, some other note would be a preferable starting point. For example, maybe if you're Beethoven, like to compose in E flat, so maybe Beethoven would be more comfortable with having E flat being 0. Okay, in any case, so we have some tonic chosen, and then this is the major scale built on 0. 0, 2, 4, 5, 7, 9, 11. Those are all familiar, I hope now, with intervals 2, 2, 1, 2, 2, 2, and then the 1 is back to 0, but I'm not going to write the last 0. Okay, so what we have here then is the various scales, and these adjacencies represented by these red lines are connecting the scales which have maximal overlap. So this next scale here, which starts on the 7, okay, 7, 9, 11, 0, 2, 4, 6, the overlap is very strong. There's a common 0, 2, 4, not 5 and 6, but 7, 9, 11. So the only difference between these two things is the 5 and the 6. Otherwise, they share exactly the same tones. So we could describe the transition going from here to here, maybe make an arrow here, okay? And going from here to here involves changing that 5 to a 6. So bumping up, okay? So we're going to denote that here by putting 5 and a little sharp sign. Sharp meaning go up one step. So to go from this scale to this scale, we're raising the 5th to get the 6th. And then similarly, we can carry on. So if we think about the difference between this one and this one, they share a 2, a 4, a 6, a 7, a 9, 11. The only difference is 0 and 1. So to go from here to here, we're taking the 0 and we're bumping it up to a 1. Okay? And what happens with the next one? The common thing is everything except for the 7, which goes to an 8. So it'll be, we have to sharpen the 7. And then from here, the 2 goes to a 3, so we have to sharpen the 2. And then from here, I guess we should put arrows here. And then from here to here, the 9 goes to a 10. And from here to here, the 4 goes to a 5. Now at this stage here, we are arriving at the scale which is sort of the furthest from the original one in the sense of sharing the least number of common notes. So how many common notes do they have? The 6, no. The 8, no. The 10, no. The 11, yes. The 1, no. The 3, no. The 5, yes. So they share the 11 and the 5. There's only 2 in common between these ones. Now on the other side, I want to go in the other direction. So there's another way. There's another scale which is very close to the original one. This one is sort of like 7 up. But there's also 7 down, or another way of saying it is 5 up, because 5 and 7 are complementary in the world of modulo 12 arithmetic. So that's the scale starting on 5. Okay? So in ordinary nomenclature, this is a perfect 5th. This is a perfect 4th, if you like. Okay, so this one here, 5, 7, 9, 10, 0, 2, 4, shares most of these except for which one? The 11. The 11 has changed to a 10. So it's actually gone down. Okay, so we're going to denote that by having 11 here, and then this is a little flat signature. That means go down one step. So sharp goes up one step, flat goes down one step. Okay, so similarly, to go from here to here, which one changes? 0 to 4. The 4 has to change to a 3, otherwise 5, 7, 9, 10 are the same. So the 4 is going down, so we'll put a 4 flat there. Okay, and then in the next one, this 9 is going to an 8, so we should put a 9 flat. And then the next one, the 2 goes to a 1, so we're flatting the 2. And then from here to here, the 7 is going to a 6, so we're flatting the 7. And then from here to here, the 5, 6, 8, 10, the 0 is going to an 11. Okay, so we're flatting the 0. Now notice that there's some pattern here. You probably already observed that when we were going down here and raising subsequent ones, we were essentially going up by 7 steps. So we're going from 5 to 0, that's a step of 7, because 5 plus 7 is 12, which is 0, and then up by 7 again, and then up by 7 is 14, which is the same as 2, then up by 7, which is 9, and up by 7 is 16, which is the same as 4. And on this side here, what we did, we started with 11, we're essentially going up by 5, the complementary thing. Or if you like, down by 7, same thing. Okay, so down by 7 or up by 5, maybe it's easier. Up by 5, up by 5, up by 5, up by 5. And in both cases, we end up with this one here. So this one here can be obtained by 6 sort of 1, 2, 3, 4, 5, 6 sharping stages, or by 6 flatting stages. So we get an interesting structure here, that these 12 scales form a nice symmetric pattern with respect to this adjacency, where the adjacency is in terms of the scales being close to each other. And musically this is very important, because if you're playing a tune and you're in this scale here, you're playing in a major scale, and say it's this one here, and maybe you want to create a little bit more interest, so you want to change some of the notes a little bit. It's a standard sort of understanding that a nice way of doing that is to move along on this wheel to other scales which are not too far away from the one that you're starting with. Okay, so you can you can go from here to here. That's a very nice step, or from here to here, or maybe you can go from here to here. Okay, in which case maybe to get back you might want to go back like this. Okay, so that's really the circle of fifths or circle of fourths, depending on how you want to think about it. That's really a very key sort of structural feature in a lot of music, both classical and modern. That's really being captured here. So we're getting a clock face, still a 12-fold kind of circular pattern, but it's a little bit different from the regular one, because the scales are starting 0, 7, 2, 9, 4, 11, 6, and in the other direction 0, 5, 10, 3, 8, 1, and 6. So here is essentially that same diagram, but just condensed. Now I'm just showing you the starting positions of each of these scales. Okay, we're talking about major scales starting on 0, 7, 2, 9, etc. And here are the various changes that we need to take to go from one scale to the adjacent scale, either by raising tones in this direction or by lowering tones in this direction. And there's some nice features here that sort of appeals to us immediately from a mathematical point of view. If we just look at the black notes, first of all, which is basically just the cycle of fifths, okay? But it's expressed in our numerical language. So 0, 7, 2, 9, 4, 11, 6, 1, 8, 3, 10, 5. And you can think about that as just counting by sevens mod 12. That's what we're doing, going around. Adding 7, 7, 7, 7, 7, 7, 7. That's also an adding 7, 7, 7, 7, 7. Or in the other way around, we're adding 5, okay? And so that's a little bit of a departure from the usual clock that starts 0, 1, 2, 3, 4, and then has an 11, 10 here. So it's probably important for me to mention, I don't think I've stressed this very much previously, right? But the numerical system of mod 12 arithmetic, I've talked about how 12 is a highly factorable number, so it has a lot of divisors, and that's quite important in terms of creating uniform scales. On the complementary side of that, the numbers in that range which do not have common factors with 12, which are so-called relatively prime to 12, there's actually 4 of them, okay? 1, 5, 7, and 11. Those are the 4 numbers in the range 0 to 12 which do not have a common factor with 12. And they play a rather distinguished role, number theoretically, but also musically. And that's a sort of a reason why the circle of fifths, or circle of fourths as it's usually called, we would prefer circle of 7 steps, circle of 5 steps, okay? Why this plays such an important role. Sort of analogous to the more familiar clock where we have sort of, going up by ones, or if you like, going up by 11s. Okay, so that's one feature to note. And the other thing is, if we stare at actually these black numbers for a second, we see a seeming coincidence, okay, which is well worth noting. The coincidence is that the even guys are exactly in the usual spots that we would expect if we had a regular clock. 0, 2, 4, 6, 8, 10, back to 0. We're going up by 7 rather than by 1, but nevertheless, on the even positions, we're exactly in the same place as we would be if we were going up by 1. So even corresponds to the sort of standard clock positions. What about the odd positions? Okay, naturally enough to ask about that. So what can we say about 7, 9, 11, etc.? Well, a moment's thought shows us that, on the clock, 7 o'clock is down here, and 1 o'clock is up there. So it seems that these two have changed places from what they are usually on a clock. Does that work for the other one? So here's 9 and 3. Yes, usually this is 3 o'clock and that's 9 o'clock, but they've changed places. And also 11 and 5, they've also changed places. So the odd positions are also pretty close to the clock positions. It's just that they've sort of swapped with their diametrical opposite. That's a pleasant feature. Now, what about these various steps that we've taken to go from one scale to an adjacent scale? That's also interesting. So here we had 5, sharp 5, and then a 0, and then a 7, and then a 2, and then a 9, and a 4. And if we just look at these blue numbers here, and we see that it's really the same pattern as in the black ones. So here's a 5 corresponding to that, then there's 0, and then there's 7, and then there's 2, and then there's 9, and then there's 4. Now, why isn't there 11? Well, there would be if we kept on going in this direction. Okay, if we kept on going in this direction, you'd have to put an 11 here if you're thinking in terms of how to go from this one to this one by raising something. Because lowering the 0 is the same as raising the 11. Okay, start from here and you lower the 0, which is in this scale, you're going to get an 11. So that correspondingly go from here to here, you have to take that 11 and you have to raise it to get the 0. Okay. So that's exactly the same as it's appearing here, and of course the same is true in the other direction. So here we have 11, 4, 9, 2, 7, etc., corresponding to 11 here, 4 here, 9 here, 2 here, 7 here, etc. So there's also a very natural pattern in the various steps that we have to take to go from one scale to an adjacent one. In other words, the raisings, the sharpings, or the flattings that are involved as we go around either in this direction or in this direction is also ultimately a 7-step procedure or a 5-step procedure. So there's something quite pleasant about this story. Okay, so I also want to show you the standard, more familiar form of that same sort of cycle of fifths, or cycle of fourths, or cycle of 7 steps, cycle of 5 steps, where we take the 0 note to be C. Okay, so the standard piano-oriented framework. So in that case, the standard circle of fifths looks like this. So C, up to G, then D, A, E, B, F sharp. In the other direction, it's like going down a fifth, okay? So down a fifth to F, then to B flat, E flat, A flat, D flat, and then to G flat also. G flat being the same as F sharp. So probably if we're going in this direction here, it'd be more natural to call this F sharp. If we're going in this direction here, we more naturally call it G flat. And remember I talked about this when we were talking about Pythagorean sort of tunings, that if you try to tune things with perfect fifths this way and perfect fifths this way, then it's exactly here that you end up with 2 different versions of what this tone should be. And in terms of the sharps, going from here to here, here was a 5 sharp. We had to sharp the 5th note of C. Well, the 5th note of C is F. Okay, so it actually becomes an F sharp. And then the next one is a 0. So with respect to C, that would be a C sharp. And the next one's a 7. So it's like 5, 0, 7, 2, 9, 4. Okay, those are the various sharps that are involved. So we end up having an F sharp, and then a C sharp, and then a G sharp, and then a D sharp, and then an A sharp, and then an E sharp. And this sequence of sharps is actually very important in modern music theory and practice. And equally important on the other side are the sequence of successive flats that we need to introduce as we go around the circle in this direction. So a B flat here, so remember that corresponds to 11, so 11 and then 4, etc. So a B flat and then an E flat, an A flat, a D flat, a G flat, and a C flat. So those are the successive changes that we need to go from one of these scales to the next adjacent scale, which differs from it just by one tone. And it's these sharps and flats that are on the outside here that are the basis for our modern key signature notation. Okay, so here we see the standard notation that we use to describe notes in terms of 5 lines for the treble clef, typically for the right hand on a piano, and 5 lines in the bass clef, typically for the left hand on the piano. And I'm showing you here the various sharps and sharp arrangements and also flat arrangements that correspond to playing in different keys. So this is going to be quite important for us. So let me just preface it by pointing out yet again that this is very much piano oriented. Okay, this is something that would not occur to an instrumentalist unless they were playing a keyboard. But it's a consequence of the particular architecture of the piano or an organ or harpsichord in terms of black notes and white notes. The white notes are getting preferential treatment here in the sense that the white notes correspond to the lines and spaces in these two clefs. So in the treble clef, that line is E and then G and then B and then D and then F, while the spaces are F, A, C, E. So, you know, it kind of goes up E, F, G, A, B, C, D, E, F. So we've gone up the white notes on the piano from an E down here to an F up there. And if we wanted to go a little bit further, well, then we could put one on top here, then that would be a G. And then we could, if we need to go further, we typically make some new lines just of small extent to position notes higher up or further down or also down here. In the bass clef, it's different. We start with a low G there, and then there's an A, and then there's a B, and then there's a C, D, E, F, G, A. Again, just the white notes. So if we just put a note either in the space or on a line, it's corresponding to a white note on the piano. So the problem is, how do we get at the black notes, and how do we sort of systematically describe being in a different key? The white notes are in the major scale of C. So if you're playing in C, you're just using white notes primarily. But if you're in some other key, you're using black notes, and this system of sharps and flats represented here is our way of encoding that. So let me explain that. So this corresponds exactly to the scales, you know, that we had on the over actually right here. So C, G, D, A, E, B, going down this side here. These are the scales that require sharps. Okay, and the sharps are then done in sort of this sort of standard fashion. And the way you should read this is sort of from left to right. So a typical piece has, not all of these, but we'll just have some of them, read from left to right up to a certain point and not the rest. So if you're playing in C, there are no sharps. If you're playing in G, it's just these two. There's an F sharp, that's an F. Okay, and that's also an F. Okay, so both the treble clef and the bass clef are alerting you to the fact that when you see an F in a piece of music, like if there's an F there, instead of playing the white F on the piano, you have to play F sharp, the adjacent black note, just one step up. Okay, that's in the key of G, and that's sort of corresponding from here to here. There was an F sharp that you had to introduce to go from the scale of C to the scale of G. To go from G to D, you have to add another sharp, and that was the C sharp. That's this one here. There's a C, there's another C. Okay, so that's the key signature of the D scale. One more sharp, 3 sharps, 3 sharps. That's the A scale. One more, 4 sharps, 4 sharps, that's the E scale. 5 sharps, 5 sharps, that's the B scale. And 6 sharps, well, that's F sharp. And typically, that's as far as we go. But there is an important, interesting exception, which I'll tell you about some other time. But typically, that's as far as we go with the sharps. On the other side, we describe things in terms of flats. Again, starting with no flats for C. And then as we move in this direction here, we're adding flats. So to go from C to F, we need to flat the 11. Which one is the 11? The 11th note in C is B. So we have to have a B flat. That's what this thing here is. So that's the note B in the treble clef and in the bass clef. So just a single flat here and here, that tells you that you're in the scale of F. Go one further, you're in the scale of B flat. 2 flats, 2 flats. 3 flats, Beethoven's perhaps favorite key, is E flat. 4 flats, that's A flat. We're going down here. 5 flats, that's D flat. And by the time we've gotten to 6 flats, we're again at G flat. So all 6 flats and all 6 sharps are really essentially the same key. They're just different ways of representing the same key. We've gone around this circle of fifths or fourths, or in our notation, circle of 7 steps and circle of 5 steps to get to the opposite one, which is the furthest away from C. It's the note built on note 6. Okay, so that's the usual story, which is so hugely familiar. It's sort of second nature to pretty well all modern musicians. But we really can ask, about what we might think about in terms of alternatives to this. Okay, because it clearly is very prejudiced towards piano players, and it's actually quite cumbersome in some ways. So young people have to spend a lot of time and effort getting all these key signatures and all these different scales into their heads in the right way. So could we avoid that by having a somewhat more sensible system? Very likely we could. Very likely we could. I'm Norman Wildberger. Thanks for listening.